Hello everyone. In today's session, we are going to discuss about alpha-beta pruning. So this is an advanced version of your Minimax algorithm. What an Minimax algorithm do? It searches for the entire tree and it tries to find the value that is there for your root node. Okay, so the possible outcome of this tree will be taken over here. After this Minimax algorithm, one player tends to maximize the function where the other player tends to minimize the value. Okay, objective function. So by this play, what will be the possible outcome that we can get for the root node? So that is your min-max algorithm works. Okay, and it is going to explore all the branches. Whereas in your alpha-beta pruning, as the name indicates, we are going to prune the tree. Okay, we are going to use two variables, alpha and beta, one for maximization and one for minimization. So here we are going to use alpha for all your max function and beta for all your min function. And we have a comparative analysis between this alpha and beta based on the value that is predicted. And we are going to prune the tree with the formula. Okay, just note down the formula. I'll just show you how it is working. So max and min are the function that you're going to have. For max function, whenever a value is found and if the value is greater than or equal to beta, we are going to prune the tree. Okay, for min, I'm sorry, it is min. When the new value that is found is less than or equal to alpha, we are going to prune the tree. Okay, in case of maximization function, we are going to update this alpha value. In case of minimization, we are going to update this beta value. Just note this alone. Okay, so initially we are going to have all default value for alpha, beta and values. Usually you'll have this infinity constraint. So when you are setting the value for maximization, you can set it as minus infinity. Okay, the reason is whatever you compare with the minus infinity, the value, like when I compare 7 and minus infinity, 7 has the highest value. So that will be taken into constraint. And similarly, when you are setting the default value for beta, set it as infinity. Okay, since we are going to find the minimum value, even 1 compared with infinity will be your 1 will be your outcome. Okay, so default value you can set. And the flow actually works like your depth first search. Okay, we start from the starting of root node. We traverse till the end of the depth. Okay, leftmost leaf node, and we start exploring this tree like this. Okay, so that is how your depth first search works. And this value that we have set for this alpha beta, right, that will be flowing from the root node to the leaf nodes. Okay, so this value for B will be set like your min-max algorithm. There is no change in it. So first step is we'll just start with the default values. So this empty set will be passed over here. V is equal to alpha equal to beta equal to. So we start exploring the first tree. Okay, so here it is a maximization function. I'm going to search till the end. So the first value I'm going to find here is 7. So 7 will be updated as your B value. Okay, and alpha value as 7. So since in this maximization function, we are going to update the alpha value. Okay, so alpha value will be updated as 7 and explore the next branch 3. 3 is again. So here you don't have anything with beta, so no need of this comparative analysis. Okay, so the comparison will work only after certain exploration. Okay, even if you compare, this is null. Okay, so you can take it as whatever value that you're going to take initially will be updated. Okay, so next 3 will be taken and it is a maximization function, right? 7, you have already a greater value. No need to update again. 2 will be explored, compare it with 7. 7 is the maximum value, so done. Okay, so this will be passed, this 7 value will be passed to the min node. Okay, I hope it is clear, the first step. First step, with beta value as null, we are not going for this comparative analysis. We just update this value of B and alpha alone. Okay, so find the maximum of this node that will be updated as 7. That is 7. It is updated as alpha value and the B value. Okay, V is the actual value that need to be found. And it is then passed this min value. Okay, so what function we are going to do it in min? We are going to update the value of beta over here. Okay, so alpha is already a default setter. We are not going to do anything with this. So this 7 will be copied over here. And the beta of 7, the 7 value is again copied to this beta value over here. Since min function is going to update beta. Okay, so this you have to have an idea of it. When it is an max function, we are going to update alpha. When it is a min function, we are going to update this beta value. Okay, now this alpha beta value will be passed to this place. Okay, so this beta of 7 will be passed over here and alpha is empty here. That will be default value will be set as it is. Okay, now I'm going to explore these branches. When I am explored these branches, what happened? Already we have this V value as 7. So now after exploring the first node, you have 8 here. Okay, compare 8 and 7, which has the maximum value? 8 has the maximum value. So when it has the maximum value, we are going to update this and update the alpha value. Okay, so after exploring this branch, now alpha is turned as 8 and this value of alpha is greater than or equal to the beta value. Beta value is 7 and this explored branch has the higher value. So in case of max function, if you get the first node with the maximum value, we are not going to bother about the remaining branches. So how much ever remaining branches we have, we are going to prune that and we are going to pass this value alone to the node. Okay, so now 8 will be stopping the process over here. This branch will be pruned and we are going to pass this value of 8 to this node. Okay, and what happened here? This is min function, right? In main function, one value is 7, one value is 8. So we have 8, already 7 over here and we have 7, 8 as the value of this max function. So comparing these two, 7 has the minimum value. So this value of 7 will be passed to the root node. Okay. Hope it is clear, right? So next step, what I'm going to do, I'm going to update the value for this max function. So whenever it comes to max, the value will be passed to the V function and alpha. When it is max, alpha value will be updated. So this 7 will be updated over here. So this value will be flowed for the remaining nodes of this branch. Okay, so we're going to have this V as 7, alpha as 7, beta as the default value. We are going to send it over here. Again, explore the branch. This, whatever is the parent value, that will be passed to the children node. Again, you have this V as 7, alpha as 7, and beta, we are going to explore it. Okay, so beta is your new node. Now it is again a max function. So what a max function do? It search for the node and try to update the value. Okay, so now what happened here? Max function is trying to maximize the value of it. And what I am going to explore here, the node is 2. Okay, the value written over here is 2. And already we have a value of 7, which is greater than 2 existing. So we are not going to update it. Okay, and we compare this with the default value. Beta is nothing, right? When there is nothing, you don't want to proceed it over here. Okay, we can keep it as it is. Okay, so next step, I'm going to explore this branch for 3. Again, here 3 value is lesser than 7. So 7 is the maximum value. We don't want to update anything. We just need to pass this 7 to the root node of it. Okay, so while passing this value to the root node, what happened? Now I have this beta value to be in min. I'm going to update this beta value. So this 7 will be updated into this place. Okay, so when I am updating this 7 into this place, we have all this value of V alpha and beta as 7. So here the condition is when this V value is less than or equal to alpha. It is 7 and alpha value is also 7. Okay, in min function, when you got this value explored and the existing value is also same, we are not going to proceed with the remaining possibilities. Okay, we can directly prune this branch. Okay, so this is how your alpha beta pruning algorithm works. Okay, I hope it is clear for you. So each step, the parental value will be flowed to the children node. And after exploring the steps, if there is any possible updates, we are going to proceed on it. There is no update, we can stop the process. Okay, so when you actually found a best node, you are not going to find the remaining possible nodes out of it. Okay, so after this, what happened? This 7 will be passed over here. Already we have this 7 in the maximum node. So maximum value is 7. Okay, so we are not going to go through this remaining part. We just going to explore, like push this amount of values to the top, and this is a maximization function. So maximum of 7 and 7 is going to be the same. So we're going to return the value. The output returned will be 7. Okay, so this is how your alpha beta pruning works. Okay, is that clear? Thank you.